Let's look now at graphing the cosecant and secant functions. This will rely heavily upon your understanding of how to graph sine and cosine functions. So if you have difficulty with that, you'll want to go and review those videos and practice in the homework. So as we look at the graph of cosecant of x, the first thing I want to show you is the graph of sine of x in red dotted line. So you'll notice that we have some shared points between the curves, namely the low points of the branches and the high points of the branches. And any time that we have a intersection of the sine function and the line of oscillation, in this case the x-axis, we have a vertical asymptote. Because of the relationship between the cosecant function and the sine function, the periods will be the same. So the length of one cycle corresponds to a period of 2 pi for the cosecant function. As we look at the secant function, it's very similar. Notice we have the cosine function, and where it intersects the line of oscillation, we have a vertical asymptote, and we have some shared points on this curve as well. And likewise, we have a period that is 2 pi units. So if I start here, or if I start and cover these 2 branches, the length of one cycle is 2 pi. So to graph a cosecant or a secant function, you'll want to first graph the corresponding reciprocal function. So if you want to graph a cosecant function, you'll graph the same function, but you'll replace cosecant with sine. Or if you want to graph the secant function, you'll graph the same exact function, but replacing secant with cosine. You'll identify any vertical asymptotes. Those are the places where the sine function or the cosine function would intersect its line of oscillation, and then plot any shared points. And the shared points would be the high points and low points of your sine or cosine functions. So let's take a look at y equals secant of x. So to graph y equals secant of 2x, we will replace secant with cosine. So we will graph y equals cosine of 2x. So the amplitude of this function is 1, but we have a horizontal compression of 2, so that means that our period, instead of being 2 pi, will be then divided by 2. And so this means the period is merely pi. And if we remember, our increment is our period divided by 4. So let's make a table of values. So we have 0, and we'll work with our increment, adding pi over 4 each time. The cosine function starts off the line of oscillation and above it. So our line of oscillation here is y equals 0. There is no vertical translation. And so we'll use our amplitude to determine how high up from that line of oscillation we go. And then we go back to our line of oscillation and down and back and to where we began. So now let's look at marking off our x-axis. So our beginning value, we can have a 0, and then we'll just increment using pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4. And now let's look at where x equals 0, and that will determine where our y-axis is. So now that we have our y-axis, let's go ahead and sketch our cosine function. We will use a dashed line because this is not the function that we are actually wanting. This is merely going to be used as a guide to graph our secant function. So now let's go ahead and find our vertical asymptotes. And our vertical asymptotes are where we cross the line of oscillation with our cosine function. So pi over 4 will correspond to a vertical asymptote. So we have a vertical asymptote of x equals pi over 4. 3 pi over 4 likewise. And now we will look at shared points, and our shared points will correspond to the maxima and minima. So once we have our shared points, we know that we are going to approach our vertical asymptotes, and there we have our graph of y equals a secant of 2x in blue. Now, we are supposed to find the domain and the range of this function. So you'll notice that there are breaks in the domain corresponding to our vertical asymptotes. So we will not write this in interval notation. We'll simply say the domain is the set of all x's where x cannot be, and let's just pick a value that x can't be. So in this, it's reasonable to say pi over 4. We'll just pick a domino to start from. Now, how long is it before our next value that we cannot allow x to be? So from pi over 4 to 3 pi over 4, this is an increment of pi. Likewise to our next asymptote, pi. So it's every pi units. So we would say plus pi k. The range, we can write in interval notation, and it's from negative infinity all the way up till negative 1. Then we have a break until we pick back up at 1, and we go to infinity. So now let's look at a cosecant function. So in this cosecant function, we will begin by graphing y equals negative 2 plus sine of x over 4. Now, maybe it would be best to rewrite that as sine of 1/4 x subtract 2. So what we see with that 1/4 is a change in the period because it's a horizontal stretch. So the period of our sine function is typically 2 pi, but we will divide by the coefficient of x, so we will divide by 1/4. That means that the period is actually 8 pi. There was no vertical stretching or compressing, so the amplitude is still 1, but you'll notice that there has been a vertical translation moving everything down 2 units. So this means that the line of oscillation is now y equals -2. So let's go ahead and come up with a table of values. And again, you might be comfortable with graphing now that you don't have to draw this table out. Oh, I forgot to write out our increment. The increment is 1/4 of our period. So the increment is 8 pi divided by 4, which is 2 pi. So let's go ahead and mark off our x-axis. So we'll start off with 0, and we'll increment by 2 pi. 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi, 16 pi, 18 pi, 20 pi. Then we will mark off our y-axis by finding x equals 0. So now that we have our y-axis marked off, let's go ahead and find our line of oscillation for our sine function. And then we can now graph our sine function. So we start off at 0, we go up our amplitude and back and forth. Now let's find our vertical asymptotes, and that's where we cross the line of oscillation with our sine function. And now we will find our shared values and graph our cosecant function. Now let's find out what our domain and range is. So the domain, there are breaks, and we first state one of the breaks, which could just be x equals 0. And then we have another break at 2 pi units later. So 0 plus 2 pi plus another 2 pi plus another 2 pi. This would be x equals 0 plus 2 pi k is 2 pi k. And we can't allow that to happen. And then the range would be from negative infinity to negative 3. There's a break until we get back to negative 1 on to infinity. So let's look now at y equals 1/4 the secant of the quantity of the sum 2x plus pi. So to graph this, we'll first look at y equals 1/4, and we'll replace the secant function with its reciprocal cosine. So we have 2x plus pi. Now, to understand what's going on there, we must write cosine of 2 times the quantity x plus pi over 2. So now we see a change in the amplitude, we see a change in the period, and then we see a phase shift of our cosine function. So the amplitude of our cosine function is 1/4. Keep in mind that when we're talking about the amplitude here, we're talking about the amplitude of the cosine function, not the secant function. The period is 2 pi divided by that coefficient of 2. And then we have a phase shift that moves this left pi over 2 units. So if we're going to write out our table for our cosine function, we have a beginning value of negative pi over 2 because we've shifted to the left pi over 2 units. Oh, and I forgot to simplify the period and find the increment. So the period is pi and the increment is pi over 4. So we will move from negative pi over 2 by pi over 4 increments. So instead of thinking negative pi over 2, it would be beneficial to think negative 2 pi over 4. So negative 2 pi over 4, negative 1 pi over 4, 0 pi over 4, 1 pi over 4, 2 pi over 4. Now we start for the cosine function off the line of oscillation, which was not moved from y equals 0, and we start up the amplitude, so 1/4, then back, down, back to the line of oscillation, and to where we began. So let's go ahead and go to our x-axis and tick off our x values, starting with the beginning value and moving by our increment. So our beginning value is negative pi over 2. Then negative pi over 4, so negative 1 pi over 4, 0, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And now we look for x equals 0, which will determine our y-axis. And so we'll go ahead and mark off the cosine function that we were trying to graph by starting off the line of oscillation, moving to the line of oscillation, and down and back. Now our vertical asymptotes are where the curve intersects the line of oscillation. And now for the shared values. And we can draw the curve. So now we've drawn up to this point a little over 2 periods. And now we'll notice that we can have vertical asymptotes, or that we do have vertical asymptotes at, say, x equals pi over 4, and then pi units later, or pi units backward. So we just need to pick a starting point